Hey Algebra 1, today we're talking about regression. Regression is the idea that you're given some experiment or some data points and your goal is to build an equation that would model that data as close as possible. So we really want to lock in on the word regression. That's an action word, tells us what to do. Correlation coefficient, that is a value that describes how close the points are to the equation that you came up with. And then state whether you think it's appropriate that you wrote a linear equation based on the data set. And then let's round our answers to the nearest 10,000th. So here's the general idea. We're given some data points, and let's just kind of estimate some basic points here. Let's say 1, 2, 3, 4, 5. And let's say 5, 10, 15, 20, 25. Just as a quick estimate. So 0, 5 would be here. We have the point 121, that'd be somewhere here. And then we have 2 making 34, so that's way up here somewhere. And then 3 came down a little bit to 31. And then 4 made 18, maybe somewhere like right here. And then 5 makes 3. So somewhere right there. And the first thing you got to ask yourself is, do I really think this is linear? Well, probably not. You may even think it's more quadratic. It's more of a U-shaped graph. And so later when you are thinking about what equation you should be getting, we should be running more of a quadratic regression. But this does determine what the linear equation would be and what that correlation coefficient would be. And so let's run some numbers. So time is going to be placed in list 1 in the calculator. And height is list 2. It's kind of like you have time is your x value, height is your y value. So we're going to go into the calculator and give it all the information, stat, edit. And so I've already put in list 1 and list 2 all of the values for the time on the x and the height for the y. And so once you have all the values correctly placed in the calculator, let's go back to stat. We're now going to calculate a little bit with it. And number 4 is linear regression. So once I calculate it in the directions, it wants me to round to the nearest 10,000th. So that'd be 4 decimal points, negative 0.62857, or around that, 6286. Y equals AX plus B. They tell me that my A value is negative 0.6286. And then they also tell me that y-intercept value is 20.23809. So we'll round that to the nearest 10,000, 2381. Now, we have an equation, but sometimes we need to know, well, like, how strong is this equation? Is this equation accurate? If I plug in 2, how close do I get to 34? If I plug in 5, how close do I get to 3? And that's what the correlation coefficient is trying to describe. And that value is very weak. So let's talk about R. R, really you want to think about it absolute value. You know, the closer it is to 0, the weaker it is. And the closer it is to 1, the stronger it is. Now, if you remembered, over here we talked about how this is not very linear. And if you think about the equation, the y-intercept is roughly 20. And then you're going down 0.62. So it's like you're going up 1 over, or down 1 and over 2. And so that line that I just drew does not model those points very closely. And that's why that R value is so weak at negative 0.09. That value is a weak negative correlation. Negative because the slope is negative. Negative 0.628 is negative for the line of best fit, slope. But weak because if you notice, all of these points are really kind of far away from the line. They're not very close. That one's kind of close, but not many of them are following that trend very well. So I do not think this is appropriate. I would say not appropriate. And part B is saying, well, let's use this to estimate the height at 10. So I'm going to do negative 0.6286x, but I want to replace 10 for like a new time, plus 20 point, we got to remember, 2381. And so this comes out to be 13.9521. And that's when x is 10, or when the time is 10. Now you may think, I don't think that's going to be a very good model, because it was kind of trending down, and this 13.95 suggests that it's going to come like back up here in a little bit. And that's kind of why we want to talk about the correlation coefficient. This isn't modeling it very well, and so we may want to pick a different type of regression. So let's look at another one. 0, 1, 2, 3, 4, 5. And for my height, let's think about the height of 63. So let's do 10, 20, 30, 40, 50, 60. So let's say you're up here at 63. And let me put in some units here in case you're not tracking with what I'm saying. Let's say you start at 0, 63, and then 1, 56. And then 2, 42, and then 3, 36, and then 4 gives you 28, and then 5 gives you 12. And see, this looks much more linear. Just in that sketch, you can tell that those points are going to line up fairly well. So I expect my correlation coefficient this time to be much closer to 1, because that is what we mean by strong. All the points are close to that line. So let's go back to the calculator, stat, edit, and I want to clear enter that second list and put in the values 63, we got 56, 42, we've got 36, 28, and 12. And so now I go to stat, I go over to calculate, and let's get another linear equation. And when I run it this time, you will see I have a negative slope, 0.8571. And then I also have a y-intercept of 64.1428. I think we're going to have to round it though. 1429. Again, rounded to the nearest 10,000th. But for the R value this time, notice that it's negative 0.991 if you were to round that. This is very strong, so this is a strong negative correlation coefficient. And that just means strong means all of these points are just very close to my line, which means that the equation is accurate for predicting future values, or hopefully you think they will be accurate. So we're going to do that same thing. Let's replace x with the number 7. So negative 9.85, gotta do some memory here, 7.1, and this is where I'm going to plug in x is 7, plus 64.1429, if I remember correctly. So when you plug in 7, that gives you negative 4.8568. Okay. And I feel like this value is going to be much more accurate, because if you were to trend this later on, it's going to fall into that negative. It's going to fall below the axis, which makes me think that this number is correct. So I'm going to give you one to do on your own, but I'm going to give you a hint. When we do years, a lot of teachers encourage students to change the year values to 0 for the initial one. And the reason is because you don't really want to start your graph way down here at 2011. That's going to really make your numbers kind of weird and hard to understand in context to the problem. So the first thing that we're going to do is we're going to drag that 2011 all the way to the origin and make that 0. So every year after that is years since 2011. So 2012 is 1 year later. 2013 would be 2 years later, and so forth and so forth. So whenever you try this one in your calculator, make sure that you do not use the year values. Try to use a 0 through 5, unless your teacher told you to do that, and that would be more appropriate in that case. So let's try to connect some ideas with that R value. That R value is what we call a correlation coefficient. And so the first thing that you should notice is the positive or negative trend. All of these points are trending in the positive direction. They're all going up from left to right. And so values that are negative do not make very much sense. Now, with A and B, it's the difference in strong. A is very strong, it's very close to 1, and C is very weak, it's very close to 0. Now, weak is like 0.08, that is so weak that the points would be so spread out from that line of best fit, it'd be hard for me to even draw a line of best fit. And so I don't think this one looks that weak because I could easily tell that those points were trending in the upward direction. And you can kind of think of it as like, well, 80% of those points are fairly close to that line. Like that one's very close, that one's very close, that one's fairly close, that one's right on the line, that one's right between them. You have a few points that are a little farther away, but for the most part, I would think of this as about 80% strong. That's not exactly how you should think of it, but that's one way in your brain to kind of figure out which of these makes the most sense. For example, look how far apart these are. So I can tell it's trending negatively, but this one is not as strong as the one on the left. So I definitely want some negative values. Don't pick any positives. Now again, you can tell that this is trending down. I agree these points are fairly spread apart, but this one is so very weak that there is no way you would be able to draw a line of best fit because the points would not have any trend at all. It's like, is it going up? Is it going sideways? Is it going down? You really can't tell. But if you really look at these points, you can see a lane in which they are trending down. They're not very strong, but I would say that this one is about negative 0.6, just kind of eyeballing it. So looking at 3, I mean, this is exactly what I'm saying. Like this point here and this point and this point, that makes me think I can draw it up. However, there's other points like this one up here and this one and this one and this one that make me think I can draw down. And so this one is what I call cloudy, or really the best answer is like no correlation, 0 correlation. So these are all somewhat strong, but this 0.01 really describes how I am having trouble drawing that line of best fit. So I want you to try this one and show it to your teacher. When these are, when I have my line of best fit over these, a lot of people would say those points are falling fairly close to that line you drew there. I'm definitely seeing a negative slope here. And so think about those ideas as you begin to pick the right answer. Same thing here. Draw yourself a line of best fit and see if you can figure out which of those values really makes the most sense for those graphs. Hopefully this was helpful, and see you later.